Good morning, everyone. Thank you so much for joining us. So what I want to start by talking about today is the sort of growing community. It's, for many of you, if this is your first time coming to HashiConf, it might not be sort of, as sort of impressive as it is for me kind of looking out and seeing the growth here. But the first HashiConf we ever held was about 4 years ago, right around the same time in Portland. And it was, at that time we were thinking, could we even get maybe 150 people in a room to come and talk about the HashiCorp tools? We were surprised then. We got a little bit more than 150. We got to about 300 or so. And for us, we thought that was sort of, a massive event to be hosting. Flash forward a year, and we had our second ever HashiConf, at that time in Napa. Got a little bit bigger. We went to 500 people. For those who were there last year, we held one in Austin at 800 people. And today, around us, we have 1,200 people. So it's been definitely exciting for us, at least. And I know for many of the faces here, I've seen a few people that I've, seen at all 4 of the HashiConf. So it's exciting for us to see sort of the growing community and all the new faces that are joining us. As part of that, one of our goals has always been, how do we make these events more inclusive, right? How do we bring new faces, new people, new communities in to join us for these HashiCorp events? And so a program that we launched earlier this year at Hashi Days Amsterdam was our diversity scholarship. Really looking at how do we find folks that are interested in learning, interested in sharing their points of views, but for whatever reasons haven't traditionally been able to attend our events or other similar industry events. So this is something we rolled out for Amsterdam, really looking at how do we find folks and sponsor them to come and join us so that we can share new perspectives, new views. So what I'd really encourage is, while you're here at HashiConf, please use this as an opportunity to meet new friends, meet new people, share ideas, share your knowledge. Because for everything you know, there's someone here that doesn't, and vice versa. And so when we talk about people joining us from all around the world, I think where you really, really get to see that sort of growth of the community is when you look at the HashiCorp user groups, right? And it's kind of incredible. We started these maybe 2 years ago, and today they're now hosted in 38 countries, 74 cities, and over 15,000 members. So it's definitely fair for us to say that it is a truly global community that is joining us here today. And when we talk about what's driving all of this, I think ultimately it comes down to adoption of the tools. That's why we're all here, is we're users of these tools, or we're here to learn about them and find out ways that they can help solve our problems. And so I think it's an incredible testament to the adoption of the underlying tools. In the last just 12 months, across the portfolio of tools, there's been 43,000 commits. I also fell out of my chair when I first saw this. And of those, I think 16,000 are to Terraform providers alone. And so those 43,000 commits have been combined into a total of 80 releases across the different tool sets, right? These are bug fixes, these are security patches, these are new features, and collectively, these are what's driving the user adoption as we're solving new problems and making these tools easier to use and more mature. Where I think you really start to see the sort of growing adoption is when we talk about sort of the download metrics, right? Last year we shared at this time that we'd done about 22 million downloads over the last 12 months from HashiConf. Now if we look back over the last 12 months, that's more than doubled to 45 million downloads across the tool set. And this is not a single tool that's driving all of these downloads. This is sort of combined, all of the tools are sort of doing the sort of equal kind of growth with each other. Consul is the largest install base. It has the sort of largest downloads, but Nomad is also the fastest growing. So you're seeing sort of growth across the entire portfolio. To make all of that possible, as you might imagine, these tools don't maintain themselves. There's been sort of a growing growing employee base at HashiCorp to make all this possible. So last year, we were about 130 people strong. Today, we're about 320 people strong. So a lot of new faces here. You'll see them all wearing sort of colored HashiCorp shirts with the logo. So if you have specific questions about any of the products, any of the tools, features, things like that, please seek out the folks in the colored shirts. The colors match people's product expertise as well. What's been making this possible, this growth for us over the last year, has really been our growing set of customers. Right? This is just some of the logos, some of the names of people who are engaged with us commercially. And I think the sort of challenge for us over the last few years has been to figure out, is there a way that we can build a commercial model that allows us to continue to innovate on the open source tools, build new features, drive innovation in that space, but still make sure that the company is long-term sustainable, right? How do we find that balance of being a business that meets payroll, but also continue to invest in open source? And we feel like over the last 12, 18 months, we've sort of found that balance, where we have folks that are engaging with us and working with us on a commercial basis, but that we're adding more to the open source than we've ever done before. And this is a wide range of folks. It's everyone from financials to high tech to healthcare to insurance to media companies and much more. So today we feel very confident in the company health and are excited to be able to continue our mission. So over the next 2 days, I encourage you to go to as many of the sessions as possible. This is just some of the folks and companies that are represented and will be speaking here. And you're going to hear from a whole broad range of folks. You're going to talk to startups at the very cutting edge, showing us new use cases and new ways of using these tools, all the way up to the largest organizations that are trying to change the way thousands of applications are delivered across tens of thousands of machines. So I really encourage you, go to as many of the sessions as you can. Also use the hallway track as an opportunity to learn. There's a lot of good stuff out there, but make sure you spend some time and learn from all these folks. So when we talk about sort of what's driving HashiCorp, right, what we sort of tie ourselves to and how we see kind of the company's inception map to is really cloud computing, right? It's sort of inseparable, the sort of rise of our tools and kind of HashiCorp's mission itself with the adoption of cloud. And in our view, there's this large replatforming taking place, right? As an industry, we're moving away from purely our private data center to some mix of private data centers plus public clouds, or if we're sort of a little bit newer school and we don't have, we have the luxury of not having legacy, we might be born in the public cloud. So there's this sort of first platform transition that's taking place, but at the same time, there's this process shift where a lot of organizations are saying, how do I go faster? How do I deliver in a more agile way? And so with this is a shift away from sort of the more manual ITIL, file a ticket and wait, to more self-service, automation, DevOps type mentality of how we deliver. And in our view, this combination of both the replatforming that's taking place to public cloud, plus the entire process shift towards a more agile self-service model, affects all 4 layers of the infrastructure. It's not a minor tweak that we can just do by changing one tool or one process. It kind of touches the whole thing. And so that's our focus as a company, right? And when we talk about each of the layers, the first one for us is really thinking about how do our operators provision infrastructure now, right? We want to have infrastructure across many different providers, some of which are infrastructure as a service, some of which are platform as a service, some of which are software as a service. And we really want to do this in an infrastructure as code way. We want to get away from manually pointing and clicking or filing a ticket. We want to be able to define what the infrastructure looks like at every layer and then automate it across a diverse set of platforms. So our big focus here is really Terraform with that automation. The next big focus for us is how do we secure all of this, right? Historically, what we really depended on was we wrapped our data center in the 4 walls. We brought everything over the drawbridge, and it was sort of a castle and moat approach to security, right? As long as the castle wall was tall enough and our sort of drawbridge secure enough, the inside was safe. And I think we're seeing a shift away from that. We're starting to acknowledge that actually threats can get inside. There are software bugs. Maybe there's malicious insiders. How do we think about securing the inside of our castle as well? So here our big focus is Vault. How do we think about a first-class approach to secret management, centralizing and governing access to secrets? How do we protect sensitive data? How do we then do this in a way that we're not assuming trust of the underlying network? The next problem we look at is how do we deploy all these applications, right? We're going to have some set of containerized apps, some set of legacy mixed workload applications, and we want to be able to run these things across many different environments. And here the focus is Nomad. How do we provide a self-service experience, both for developers who want to deploy and manage apps, but also for our operators who are managing the infrastructure? And we want to do this across a diverse range of workloads, so containerized, non-containerized, Windows, Linux, the whole gamut. And how do we do this in a way that's high performance so that we can scale from a cluster of a few nodes and a few applications to clusters of tens of thousands of nodes and thousands of applications? The final challenge is how do we wire this all together, right? So great, we have our whole mix of infrastructure. How does it all discover and talk to one another? And here where our focus is Consul as a service mesh. What we want to be able to do is enable all these generations of technology to discover one another, route to one another, encrypt traffic between services, and segment who's allowed to talk to who. So together, these kind of form the HashiCorp suite. And that's how we think about it. It's a suite of different tools. It's not meant to be a single monolithic platform, right? Each of these tools has a very specific problem focus, right? Whether it's provisioning, whether it's security. And the goal is to make it easy to adopt and pick off one problem at a time. And so when we talk about the tools, it's a big focus on accessibility. So part of that is having a scope that's clean and well-defined. Part of that is making the tools easy to use. But part of that is making it easy to learn. Right? And that's a whole gamut from beginner introductions, documentation, guides, webinars, there are training sessions. There's a whole set of investments we make in accessibility of the tooling themselves. And so we're super excited today to share sort of the next step of that, which is a new learning platform we've been working on. So we just launched this. This is what we're calling HashiCorp Learn. And it's really looking at how do we provide content that's tailored to practitioners to help educate these tools, about these tools. And so when we talk about the Learn platform, it's very, very much practitioner-focused, and it's meant to be sort of a self-guided, go-at-your-own pace, right? So you can come in at any time, work around your own schedule, and work through an iterative set of courses that range from, beginner, I don't know what Vault is, through intermediate all the way to advanced use cases. And the goal of this is that it's just free, it's open source, you can come in and learn it. Our goal is to make the tools as accessible as possible. So when we talk about kind of what the focus of the platform is over time, today it's really just looking at what's the core product, the main use cases, how do we educate you on getting 0 to 60, right? Getting some value out of tooling like Vault. But over time, we want to add additional use cases, additional specific features, sort of sidetracks, because all of our tools, we like to describe them sort of like Microsoft Excel. Right? Yes, you could use it to make a recipe, you can make a to-do list, but you could also do your financial planning for Fortune 500, right? It's sort of that whole gamut. So where do you start, right? The way you teach someone to make a to-do list is a little different than you do for a recipe. And so over time, the goal is how do we add these different kind of use cases into this as different sets of modules so you can come in and learn both the sort of depth of the tool, but also the full breadth of them as well. So today, you can go visit the platform. Vault is available and has sort of a rich set of getting started content, as well as some of these additional sidetracks. Terraform, Consul, and Nomad will all be available as well by the time we get to the end of the year. So to check this out, just go to learn.hashicorp.com. And it's free. You don't need to sign in. You can just get started right away and dive into learning more about Vault. So now that we're talking about Vault, I want to switch gears a little bit and start talking about product updates. So when we first released Vault 0.1, it was April 2015. And at the time, it started out as an internal tool. We built it for ourselves at HashiCorp. We actually had no intention of open sourcing it. And it was really for us to manage our own internal usernames and passwords, API keys, certificates. We had this interesting challenge of, OK, we're using Packer and Terraform and our own tools. And how do we do secrets management in a way that's automated but also secure? So it really was born out of that need internally. And it was really pressure from our community, folks like you, to really say, hey, how do we solve this problem that drove us to open sourcing it? And so our original focus, like I said, was really thinking about secret data that lives within Vault, right? Username, passwords, API keys, tokens, certificates, all that kind of good stuff. But what quickly became apparent to us is this whole other class of data that doesn't live within Vault, right? Our sort of sensitive data. Credit card numbers, transaction information, user details, PII, all sorts of data that we're not putting in Vault. We're putting in databases or data lakes, other things like that. And how are we sort of securing this, right? And what we tend to see in practice is if it's being secured at all, it's being secured by an application that's doing cryptography itself, right? So the application is managing a set of encryption keys, and it's encrypting the data before it's writing to the database, typically. Right? And so the sort of bad part of this, right, what makes us sort of uncomfortable is how many of these applications are implementing the cryptography correctly. Right? And if you do sort of an audit, it's very few. Right? There's a lot of nuances to getting crypto correct, and so a lot of applications don't. Right? And then as we talk about key management, that's also an issue. So we expanded Vault and said, how do we look at solving the sensitive data problem? And we added a new backend we called Transit. And the idea behind Transit was we define a set of named encryption keys, right? So credit card, PII, logs, things like that. And then we could use a high-level set of cryptographic operations to go and do encrypt, decrypt, sign, verify, things like that. So as a web client, I just consume Vault to protect my sensitive data. And so as we spent time thinking about this sort of leakage problem, right, we realized there was sort of a bigger issue of credential leakage, right? So application would come up, it would talk to Vault and say, I need a database key to go talk to my database. Great. But at the same time, it's going to log that out to config and say, here's my configuration with my username and password, right? And when there's an exception, it's going to capture that in a traceback and send it out to our APM system, right? Or our monitoring tools will end up getting it. Or it'll go into our diagnostic pages, right? We render a 500 error and put our database password on it, sort of et cetera. The applications tend to be leaky buckets, right? They are not designed in a way that's assuming that they have to keep these credentials secure, and so they're sort of leaking them all over the place, right? So it's not just encryption keys. The other problem we have is sort of thinking about privileged operators, right? So we have these administrators that are either database administrators or system operators that need to be able to have access to these end systems to do what they need to do, right? But what happens is they change roles, right? Or sort of even more sort of scary to think about, what happens when they leave the company, right? Did they take any of these credentials with them, right? Because they needed them to operate. What prevents them from just writing it on a piece of paper and taking it? So this brought us to sort of the idea of dynamic secrets. And the idea here is we create these secrets just in time when the client asks for it. So the client comes and says, I need a database credential, and the Vault goes and creates one on demand. So it's unique per client and auto-expiring. And so in this way, if the application leaks it or an operator takes it with them, we're automatically rotating and revoking those credentials all the time. And so this was a feature that was landed as part of Vault 0.1. At the time, we really were only thinking about it through the lens of databases, right? What prevents sort of leakage of database credentials, right? So all the classic things, MySQL, Postgres, MS SQL, all that kind of stuff was supported as part of this. But over time, we realized this applies to other systems as well, right? NoSQL systems have the same problem. As we talk about our cloud providers, they also have the same problem, right? We have maybe an IAM token that allows you to read from S3. Well, we don't want you to have permanent access if you leave the business, right? And then things like applications, our messaging queues like RabbitMQ, right? And so on. Other applications like Active Directory service accounts, right? TLS certificates, right? SSH brokering. You don't want the master PEM file that allows you to SSH into everything. So we've expanded this sort of dynamic secret capability to a broad range of systems, looking at how do you only give time-bounded access so that you don't have to worry about these credentials leaking forever. The other thing we've been focused a lot on over the last year has been improving the user experience. This is both in the CLI as well as the web UI. So both have been totally revamped to really figure out how do we make this a much richer experience that's easier to use but has more of a sort of coverage of Vault's API, right? Historically, it was only covered sort of a small bit of Vault's total surface. So we're trying to fill that out. In addition, we've added sort of what we jokingly refer to as Clippy for Vault, sort of a little getting started wizard. It's like, looks like you're trying to add a secret. Can I help you? And we joke about it, but it's really a system like Vault is very complex, right? It has many different knobs, many different features. And so how do we make it easier to sort of get started? Like, OK, if you do want to set up a new engine, right? Maybe you're trying to set up an AWS IAM generator, there's a bunch of parameters. How do we help walk you through that and make it a little bit more intuitive how you set up Vault? And so luckily, we decided not to give it any cheesy clip art. The other big investment in Vault has been how do we make it accessible for the enterprise, right? And that's a different set of challenges because there's a different set of requirements there, right? So we first released Vault Enterprise in 2016. And what we first looked at was what are the hardware integrations that are required in an enterprise setting. That's where we started. But from there, you see there's a gamut of operational challenges from multi-data center replication to real-time backup to administrative challenges like multi-tenancy and policy sandboxing. So those have all iterated on over time to make it more suitable in an enterprise environment. And today, what you see is a much, much more mature Vault than what we had in our 0.1. We've had 45 releases since then. These have brought many new features and production hardening of the system. And today, it's very broadly adopted by the user community, and it's mission critical for many of our customers. And we were very excited this year. We won the OSCON 2018 Breakout Project of the Year award. So all of this sort of makes us very excited to talk about that journey from Vault 0.1, bringing us all the way to Vault 1.0, which we're super excited to be able to announce today. So the preview will be available today. You can go online, download it, start kicking the tires. It should be the Vault you know and love, but just with a little bit rounder of a version number. So as we talk about sort of the HashiCorp 1.0s, I think this is sort of an interesting topic for us. And we often get asked about it. Like, why do you have these tools that, you have millions of users on these things and it's still like a 0.8 or something like that, right? It sort of goes against what we tend to see in industry. And I think for us it comes to what is the bar we want to set for ourselves, right? What does a 1.0 mean to HashiCorp? Right? And for us, what it really means is, do we understand what are all the major use cases of this tool, and is it supported at that 95, 99 percentile mark, right? If you say, I'm using Vault for one of the 3 main use cases, can 99% of users just use it out of the box, and it works at their scale, it works at their level of SLA, it has all the features they need? Right? That's a major milestone for us. The other thing is, as these products evolve, their core architectures change, right? You end up realizing, oh, at this particular scale, we need to do this sort of data handling in a different way, or we need data to replicate in a different way. And so these architectures change and evolve over time as you see different use cases, different scales. And so we have to feel like the architecture is at a mature point in time where it's not going to be under rapid churn, right? So it has to have this stable implementation that we know works at scale. The other part of it is understanding what is the workflow and UX, and do we feel like that's been refined to a point that we're happy with, or is there still a lot of rough edges we need to sand down? And then the last part is things need time to bake, right? There's really no way around that. There's a certain class of bug that is only found in production. And so we feel like there has to be a broad deployment of the tool. There has to be broad usage so that it gets that production hardening. There's really no amount of sort of unit testing that sort of is the same as production. So those all have to be there before we're comfortable calling it a 1.0 release. So along with the 1.0, it's not just a version number change. There are new features as well. A big, big ask for a long time has been, how do we get access to sort of the auto-unsealing feature of Enterprise in the open source version? So with 1.0, we're sort of graduating that out of Enterprise and making it available in the open source. So for Ali Cloud, and like I said, there was a lot of community ask for it, as you can tell. So this is going to be Ali Cloud, AWS, Azure, and Google from the get-go. And so this will allow you to automate the unseal of Vault much more easily in sort of automated provisioning. So for users that are already on Vault that want to make use of this feature, we're making it super easy to do that migration. So when you do unseal, you'll basically say, I want to migrate away from Shamir and towards auto unseal. And once the key holders provide their keys, Vault will flip over to using the new mechanism. And from then on, we'll use the auto unseal capability. Right? If you decide at any point you want the manual control back, you want to be able to sort of tightly control when the unseal happens yourself, you can always migrate away from auto unseal back towards Shamir. So it's not sort of a one-way operation. You can go back and forth as you like. Another big feature we've been looking at is, how does Vault fit into environments that are sort of more edge casey, right? Particularly when we talk about serverless environments or high-scale batch processing. And what makes these environments sort of unique is they're very, very high scale and bursty, but short-lived. Right? So these Lambda functions, you might have 1,000 that come up, they process for 30 seconds, and they go away. And so they're going to create a whole bunch of traffic against Vault all of a sudden and then disappear. Right? And so this is sort of an interesting use case for us. Right? The challenge historically is Vault's tokens, when it returns to you, is just a flat UUID, and all of your session state is maintained server-side by Vault. So when this burst shows up, we create a whole bunch of session state that is then kind of garbage, right? It's valid for 30 seconds, and then you're not using it anymore, right? But it's a bunch of stuff Vault has to keep track of. And over time, this can cause performance issues if you keep having this bursty behavior. And so batch tokens are a new way of looking at this problem, right? Specifically looking at batch type use cases, which are short-lived and bursty. And instead what we do is sort of invert it. Instead of handing the client a UUID and maintaining state server side, what we do is encrypt the whole session state and hand back an encrypted session to the client. So only Vault can decrypt it and look at what the session state is. Are you still authorized? But what this lets us do is eliminate the server side state and handle these sort of batch cases much more gracefully. So even for applications that need to do thousands of authentications a second, now it's not an issue for Vault. There's a bunch of other interesting features coming with 1.0 as well, right? One that's been long asked for is migration between storage backends. So you might start off with something like a cloud blob store and then decide to migrate to Consul for higher performance or something like that. There's a bunch of replication changes to make it more parallel, more batching, to do sort of higher performance for customers that have millions of keys in Vault, as well as an open API specification for the full API. So what this will let us do is auto-generate SDKs, generate documentation, mock servers, all of that stuff can be sort of derived from the API automatically now. There's a lot more, but these are a few of what I wanted to highlight for 1.0. And so what does the road ahead look like for Vault, right? There's the immediate 1.0 release, but beyond that, we have a long roadmap still planned, right? The way we think about Vault is really as an extensible security platform. And you kind of see that when we talk about things like SSH brokering and TLS generation and things like that, is once we have this trusted core, what is the sort of surrounding set of security problems that we need to still solve, right? And how do we solve those in sort of a modular way that keeps the simplicity of Vault's core? So that's kind of how we see our roadmap from here, is what is that next set of challenges? How do we solve that in a way that we're doing it modularly and not expanding the scope of Vault Core? So now I'd like to introduce Brian Nuskowski to the stage, security engineer from Cruise Automation, to share a little bit more about their use case for Vault.
Good job. Thank you. Morning, everyone. How are you doing today? My name is Brian Nuskowski. I'm a security engineer at Cruise Automation here in San Francisco. How many of you want to be able to drive a car and not actually drive the car? Like maybe read a book or eat a burrito or whatever other things you want to do, maybe even sleep or work. So that's what we're working on at Cruise Automation. So kind of we call it the driverless revolution of autonomous vehicles. And as a security engineer, you can imagine it's pretty difficult to try to secure something like an autonomous vehicle, which is really kind of a hard project to solve. And so we kind of have three core problems we're looking to solve in the security of our AVs. One is kind of like the generic standard secret delivery, obviously. Everyone has this problem. How do I get secrets from point A to point B? The next problem is, well, if I'm going to get those secrets from point A to point B, how am I going to do that? How do I authenticate this thing that is essentially a robot? It's no longer a computer or a web app. So how do we kind of shift our thinking of we authenticate traditional things, now that's this thing that's out in the real world, and we have to prove that it is who it says it is. And lastly, how do we make sure that this vehicle is talking to other services that it really is required to talk to in order to properly operate and function and do things like take you where you want to go? So in trying to solve this solution, we essentially chose Vault to do that. And for standard secret delivery, you can imagine we just use kind of wherever possible, we leverage the secret engines that HashiCorp delivers to us. And for more complicated things like maybe component or vehicle authentication, we use a combination of public key infrastructure primitives and a lot of custom plugin development. And lastly, now that maybe this thing is able to authenticate, get secrets, now it's got to talk to other stuff, we thought, well, since we already have Vault in our ecosystem across other applications, why don't we use it as kind of the central message broker? So for that, we used a lot of interesting Sentinel, which I'm sure you'll hear more about today. So I have a talk this afternoon covering some more of these topics in detail. If you're really interested in this and want to learn more, please come check it out. And thanks for listening.
Can we give another hand of applause to Brian? So a group internally at HashiCorp that we've talked about a few times before is the HashiCorp Research Group. So internally, it's an industrial research lab, sort of looking 12+ months out ahead of our main product group. It's sort of the frontier of problems. And one of the problems that's sort of interesting for us to think about is security configuration, right? And I think a perfect example of this is imagine a perfect bug-free firewall, right? But how good is this firewall if it's been misconfigured to allow all traffic, right? And so I think this highlights an interesting challenge with security software, which is there's this sort of challenge of implementing them correctly, but then there's a separate challenge of how do we make sure that they're actually configured correctly? Because they're really no better than their configuration, right? And so this problem applies not just to firewalls, it applies to sort of all security software, including Vault, right? So as we talk about Vault, it necessarily has to be configured with how do clients authenticate, what are clients authorized to actually be able to do, and this must be configured sort of by definition in advance of the client, right? The client can't do anything until the system's been configured to allow the client in, right? So typically you have a security administrator or a Vault operator who's doing this configuration. So when we talk about sort of what we have to do, as a security administrator, I have to think about, what is this application going to need? Or what does this set of applications need? How do I authenticate it? How do I authorize it in advance of it showing up? And so I'm going to make some best guesses, right? So I might say I have a web app, an API, and a user service, and all of them need access to the database credentials and email credentials and API keys. And so I'm just going to write the policies that authenticate and authorize those servers to do that, right? And so there's some guesswork that's going into this. In practice, though, it might be that we've guessed wrong, right? And this is sort of inevitable, right? Because if we guess in sort of too restrictive of a way, if we give too little capabilities, by definition, we break the app, right? If the app needed access to a credential and we didn't give it access, it's not going to work, right? If we gave it access to a credential that it didn't actually need, it's going to be fine, right? We sort of erred on the side of giving it too much privilege and over-provision, but that's OK, right? And so this is what you tend to see in practice. Most of these systems are over-provisioned. And over time, we never really remove permissions. We sort of keep adding things. And so we kind of get more and more over-provisioned. But if it ain't broke, don't fix it, sort of tends to be the ruling mentality. So we kind of live with this, right? The challenge, I think, of living with this is what it represents is unnecessary risk, right? Is that all of these permissions that are granted but not actually used are adding risk into our configuration, right? And what makes it sort of unnecessary is that the application never needed it, right? So if our web server was compromised and now it leaked out, API keys, well, that was a risk we never had to take. It was an unnecessary one because the app didn't need it. Leaking the database credentials was sort of a necessary risk, right? The application needed that credential. There's really no way around having that risk. And so what we'd like to do, sort of the ideal world, is to never authorize it to begin with, right? To have it sort of the most restricted as possible, sort of following principle of least privilege, right? This would be the least privileged configuration of the system. So it gets into this interesting question of how do you configure these systems? What are the policies that would give you that, right? What's the perfect policy? And what you find is there actually is no such thing. There is no perfect policy, right? Like everything in life, there's trade-offs. On one side, we have our sort of complex but low-risk policy. This might be, I write a policy unique for every single client of the system that perfectly and explicitly says what you have access to, right? And so this is a very low-risk policy, but it would be a nightmare to administer, right? On the other hand, I have a very simple policy. I can say everyone in my system is root, right? It's extremely simple, extremely high risk, right? It's a terrible idea. And so what you find in the real life is something in the middle, right? There's what's the practical policy that has an acceptable level of risk and acceptable level of complexity, right? It sits somewhere in the middle of this spectrum, right? And so how do we find these middle policies, right? And that is exactly what we've been looking at solving with a new project that we're calling Vault Advisor, right? And so the idea behind Vault Advisor is how do we first start by just consuming what is happening, right? We'll kind of tail off of Vault's audit log and observe in the real world what clients, what users, what applications are consuming what set of credentials, right? We can sort of observe real-world behavioral pattern, right? And then what we want to be able to do is create a diff, right? How do we generate a policy diff between here's how the system has actually been configured versus the way it's being used in real life, right? And what we're trying to do is form a closed feedback loop, right? We want to connect back to our operator who's configuring the system and say, hey, here's a recommended set of changes. And this is a very explicit design decision. We want this to be a human-in-the-loop system because these systems are mission critical, right? And much against the sort of marketing hype, AI is not quite there yet. We don't trust the systems to go off and make these changes on their own. So how do we keep someone in the loop to be able to eyeball and say, does this change make sense? Is this a valid configuration for Vault? And if so, great, we can adopt it and update the configuration of the system, right? So the goal is, as an operator, we can come in the morning, log into a dashboard and say, what's a recommended set of changes for me to make? And what we'd like the system to be able to do is sort of explore the policy trade-offs and find the sort of Goldilocks policy, right? So if we look at this sort of configuration of the system, there's many ways we could configure it, right? One way would be we're going to write a policy per client, right? Per web server, API, and user service. We'll have 3 different policies and configure it that way. A different way would be go sort of vertical and say there's a policy for database, email, and a separate policy for API keys, right? Or you could say I'm going to have one policy that covers all of these things, right? So there's many ways to start slicing and dicing the same problem, right? But what you might want to say is maybe there's the Goldilocks of 2 policies, right? There's one that manages the database credential, one that manages SMTP and API. And what this policy does is let us only introduce a slight bit of unnecessary risk, right? We'll grant the API access to SMTP, even though it doesn't need it, but we only need to manage 2 policies, right? So we can find that sort of middle policy that makes the trade-off, right? So what makes this problem hard, and what's not sort of obvious in this trivial example, is that there's sort of an explosion in the number of possible ways of solving this, right? This problem is NP hard, right? So in this trivial example, yes, you could sort of almost visualize all the possibilities, but if you scale this up even to a matrix as small as 10 by 10, right, 10 entities and 10 secrets, all of a sudden there's a sort of an infinite number of ways you could solve that problem. So there's a sort of meaty problem. How do you actually decompose this challenge and present these Goldilocks solutions? So we don't have time to go into the details of it. There's going to be a great session tomorrow by our research team doing a deep dive into Vault Advisor and how it works. So I highly recommend for people that are interested, go check that out. The goal of the project, though, is how do we get this to general availability? Today, it's still very much a research project. We're actively recruiting beta testers, so if you're interested, please find John Curry. And we're going to publish this as a white paper. But beyond that, what we realize is that this is not a uniquely Vault problem. Anything that's a security software is only as good as its configuration. And so how do we look at broadening this beyond just Vault and really looking at what's the discrepancy between how security software is configured and how it's used? So now I want to transition a little bit and spend some time talking about Nomad. So I think often when we talk about Nomad, we're also asked about Kubernetes, right? And I think the question we tend to get is, doesn't Kubernetes obviate the need for Nomad, right? And I think the way we see it is that, as a company, we are deeply invested in both, right? We are integrating all of our tools, Terraform, Consul, Vault, in both Nomad and Kubernetes, right? So both of these ecosystems are super important to us. But at the same time, we believe that there's use cases that are just a better fit for Nomad, and our users tend to agree. And so if we look today across the HashiCorp portfolio, Nomad is actually our fastest growing tool, right? Quarter over quarter, year over year. And you're going to see talks from many large-scale Nomad users at the conference today talking about use cases where they also felt that Nomad was the best fit for their job. So when we talk about use cases for Nomad, there's kind of 3 categories we tend to see, right? One is really looking at, what if I just want a container scheduler, not a container platform? I want to be able to run my containers, but compose it with Consul for service discovery, Vault for secret management, other tooling I have for load balancing. So if I have these existing investments and really I just want a scheduler, right, not a full platform with opinions, then that's a great fit for Nomad because that's all Nomad is. It's a scheduler, right? Then there's the use case of applications that are non-containerized, right? These are Java applications. They're maybe traditional Windows applications. They're statically compiled, C++ binaries. They're things that we haven't put in containers and maybe don't want to invest in putting in containers. But how do we get some of the benefits of the self-service automation and sort of all the monitoring and kind of sort of health checking and recovery capabilities as scheduler affords us? So for those kinds of workloads, Nomad's also a great fit because we can just hand it a Java jar and say, go run this in an isolated environment. The last major use case for us that we see is sort of batch and high-performance computing, right? So Nomad is designed to be able to handle thousands of scheduling events per second, tens of thousands of cores under management. And so when we have these use cases of very high throughput, bursty traffic, then Nomad is a great fit for that, right? It's designed for this sort of very, very ephemeral infrastructure and for high-scale scheduling activity. So there's plenty of use cases where we feel like these technologies are complementary to one another, right? So within the last year, we've spent a lot of time developing out Nomad. We've added a ton of new features. There's going to be some great sessions here that I encourage you to check out. A few that I want to highlight, things like cloud auto discovery. This makes it really easy to bootstrap a Nomad cluster. Sort of give it a few flags, and they'll automatically form a cluster. Advanced node draining makes it really easy as operators for us to go in and say, these 50 machines, take it out of service. You have 4 hours, and to drain the workload gracefully. There's much better sort of node event information and telemetry that lets us understand what's happening inside of our systems to understand, why are things rescheduling, what's going on with the cluster itself. A revamped UI, a revamped CLI, lots more polish that's been making the system easier to use at scale. So now I'd like to welcome Rob Zuber, CTO of CircleCI, to share a little bit more about their Nomad use case.
Thank you, Armand. Good morning, everybody. It's a pleasure to be here. I'm Rob. I'm the CTO of CircleCI. We've been really big fans of HashiCorp for a really long time. I think we use every single tool that's in the toolkit. And also, we share a lot of the same mission and vision. as HashiCorp. So we spend a lot of our time thinking about making sure that you as developers can focus on delivering your value to the market instead of spending your time on sort of undifferentiated heavy lifting. And for what we do, we're focused in the delivery pipeline. So we offer continuous integration, continuous deployment. We primarily do that in the cloud, although we also have a server-hosted offering that you can run yourself. And globally, within our cloud environment, we do that for 25,000 plus organizations, which drives recently 12 million builds per month and climbing. And what's interesting about our use of Nomad is that it's not about scheduling the services that we built, but we've actually baked Nomad into the heart of our product. So within CircleCI, as an end user, you define a workflow, which is basically your definition of how you want your jobs on our platform to be executed. It's a DAG, effectively, a directed acyclic graph of dependencies between the jobs that you want to run on our platform. And when you've defined one of those CircleCI jobs, we then take that and convert it into one or more Nomad jobs to be executed. And so we chose Nomad as the solution for this for a few reasons. First of all, performance. We needed something very fast. We're in the delivery pipeline, and developers are waiting on their builds to be executed. So we need to get something scheduled onto our platform and executing as quickly as possible. And we wanted it to be simple. We need something that we can understand and operate within the core of our product, not that's wrapped around the whole product and brings with it a lot of complexity and baggage and layers of tools on top of tools in order to do that scheduling. We just need something that's going to do what we need done and do it quickly and be understandable. We also, as I mentioned, we deliver this as a server offering to customers who take it and run it themselves. And so built into that environment, we need it to be something that they can manage. And we found Nomad to be perfect for this environment. So we deployed Nomad as part of that in our cloud environment 2 years ago. And as of about last week, at peak load, we're running about 7,500 concurrent jobs scheduled through Nomad. That runs across about 750 clients, which are the actual hosts that are registered and taking those jobs. But what's interesting is those are not steady state jobs. They're churning very quickly. So we're scheduling about 3,000 jobs every minute and packing them into that large cluster of hosts and packing them in very efficiently because we spend a lot of money on that large cluster of hosts as well. So if you're interested in learning more about Nomad, about our use case of it, and about why these numbers actually all doubled yesterday, I'll be talking about that at 2:35 this afternoon right here. I hope you have a great show. Enjoy everything that you do, and thank you very much.
Can we give Rob another quick round of applause? Thanks so much, Rob. So I want to spend a little bit of time also talking about Nomad 0.9 and highlight a few of the new features that are coming as well. So one of the big focuses for us has been really looking at how do we make the scheduler smarter, right? And I think what we've seen over time as we get sort of increasingly sophisticated use cases like circles is people want more control over how Nomad places and schedules and manages their application. And so a common ask has been affinities and spreading, right? And the idea behind affinities is how do you hint to the scheduler that you would prefer to be placed in a certain location, right? So Nomad has always supported the notion of what we call a constraint. A constraint is something that must be satisfied, right? So if you tell Nomad, my job must run on Linux or my job must run on Windows, there's no way for Nomad to sort of fib that, right? If your app is designed to run on Linux, it's not going to work on Windows. So the constraint must be satisfied. Versus an affinity is more of like it's a thing I would like, right? And a perfect example of this might be maybe you're able to use certain kernel features that you know makes your application faster on certain platforms. Or there's certain hardware instructions that your app can potentially leverage that makes it faster, right, on certain classes of hardware. So in these cases, it's not make or break if you're not running on that environment, but you'd like to provide the hint such that if that hardware is available or if that OS is available, then all the better your app can leverage it. So what that looks like now with the latest version of Nomad is you can add this affinity block. And what you're really hinting to the system is, here's a set of things I would prefer to optimize for, right? And you can really optimize across anything you want, right? It could be operating system, it could be version of application installed, maybe a Docker version, could be hardware properties. Really anything that Nomad knows about, you can use as something to optimize your job against. And so in this simple example, we were just optimizing against the kernel version, right? So we're pinning against the kernel version and saying we would prefer to be later than 3.19, right? And maybe there's some new features that we're leveraging in that. And so we're going to say, great, if that's available, put us there. If not, find some other Linux machine, still place us there, right? And so it makes it super easy for us to sort of customize where we're placing the app. And you have this weight property that lets you sort of express a preference of how much does this matter to you, right? If it's super, super important, then great, we'll try harder and maybe move workloads around to make that possible. If it's not a huge deal, you can provide a lower weight to it. At the same time, there's sort of the reverse of that, which is what if we really don't prefer a certain class of hardware, right? And so this is an anti-affinity. And there might be reasons for that. Maybe we know that our app doesn't do well on spinning disk, right? And we need an SSD, so we have sort of a strong anti-affinity to spinning disks. Or we know it doesn't perform well on a particular version, things like that. So we can do almost the same thing as affinity, but really are just assigning now a negative weight. And just saying we negatively prefer the same attribute as we would have for an affinity. The other one that's super interesting is spreading. Right? And so typically what Nomad will do, and I think this is something Rob highlighted, is try and bin-pack applications as much as possible. Right? So we're trying to fill up the existing hardware in the fleet and maximize our utilization. So we want to get all of our existing hardware to be fully utilized before we start utilizing new hardware. Right? And so this lets us sort of scale down and get rid of machines that are effectively idle by packing in things onto other hardware. And so this is Nomad's default behavior, is this bin pack, right? But there's good reasons why we might not want to do that. We might want to specifically spread out our applications on purpose, right? Typically, it's for things like availability or modeling or sort of fault tolerance zones, right? So a perfect example of this is, suppose we have two data centers, right? Data center East and data center, East 1 and East 2. We might not want all of our applications to end up being bin-packed in East 1 so that we have East 1 at 100% utilization and East 2 at 0% utilization, right? Instead, we'd like to specify to Nomad, we want a spread between these. So you can pick any property, much like with Affinity, and say, on this axis, on this dimension, I'd like to spread workload. Right? So we might like to spread our workload between 50% East 1, 50% East 2, and then within those regions, Nomad will still bin pack. So we'll still make sure we're packing data center 1 and packing data center 2, but spreading across that dimension. So this lets you get into either modeling things like availability zones and data centers for fault tolerance, but also if you're worried about bugs in kernel versions, right? You might have a spread across different versions of the kernel that you're running against. So if there's a bug in one runtime, it doesn't affect all instances of your application. So you can pick different sort of axes to spread your workload across. Another interesting sort of property of Nomad scheduling is that it's priority based. So any job you submit to the system, you tell us what's the priority, right? 0 to 100. And Nomad tries to give preferential access to resources. So higher priority jobs get scheduled first. If there's contention on resources, they sort of win out. So we try and use this priority as sort of the deal breaker so that you can give us sort of your business logic of, hey, my front-end facing user traffic is more important to me than my sort of nightly batch processing is, right? So you can kind of encode that, and the scheduler will respect it. Now, the challenge is what happens when the cluster is totally busy, right? You have a cluster that's 100% full, and now new work shows up, right? What Nomad does is basically park it in a queue, right? There's no work, there's no capacity available, so great, put it in a queue, wait until room frees up, and then when there's room, we'll go schedule that application for you. So this is nice from the perspective of we can treat Nomad as a job queuing server. We don't have to build sort of reconcile logic of if it's busy, come back and try again. Nomad will deal with it. But you can deal with it, you can end up with this sort of priority inversion, right? So if I have a cluster that's totally full with low priority work and a high priority job shows up, that high priority job is now sitting in a queue waiting for low priority work to finish, right? And so this is a classic problem known as priority inversion. You can't have high priority work wait on low priority work. And so the way we're solving this is by adding preemption in 0.9. So when the scheduler detects that it's in this configuration, right, it's totally full, there's no additional capacity, but now we have high priority work that's arrived, how do we evict low priority work to make space for the high priority work, right? So really the low priority work can sit in the queue, the high priority work is the one that should go execute right away. Right? So we're adding this across the board. The system scheduler in Nomad, which is responsible for running all of the sort of agents that run everywhere, monitoring, logging, sort of security agents, things like that. The system scheduler is responsible for that, is gaining preemption in 0.9 in the open source. And then the service and batch schedulers are gaining this ability in enterprise subsequently. Another common feedback we've gotten with Nomad is, how do we make this thing easier to integrate with my ecosystem? Nomad is already relatively unopinionated about how things should work, but how do we make it even more flexible to bringing in different ways of thinking about running jobs or different devices, things like that? So with 0.9, there's been a big investment in the pluggability of the system. And the first two things that are showing up are task drivers. So task drivers are how Nomad actually executes. So Docker and LXC and QEMU are examples of task drivers. So when you provide Nomad a Docker job, the Docker task driver is the one responsible for executing it. But what if we want to customize that, right? We want to build our own task driver specific to maybe Node.js, or we want to take the Docker one and modify the way it actually behaves to fit into our environment. So now what we can do is support that being a pluggable thing. It no longer has to be compiled into Nomad. You can have a custom driver and do sort of specialized logic within it. The other kind of common challenge is, how do we manage sort of not stock devices? So FPGAs, TPUs, GPUs, other specialized hardware. How do we make Nomad aware of it and so that it can manage it and schedule against it? And so historically, it's been you have to make the core product aware. Where now we're adding a whole sort of driver interface so that you can plug in sort of additional devices, and Nomad will become aware to be able to do scheduling and management and resource isolation of that hardware, right? And so all of this is really part of laying the foundation to have even more plugins in future releases. So really looking at how do we make the system super pluggable and super extensible. One plugin that we're super excited about is the NVIDIA GPU one. Right? So a lot of our sort of use cases, as I mentioned, are around this sort of large-scale batch processing. And increasingly, we have users and customers who want to leverage graphic cards to accelerate workloads like machine learning. And so if you have a super parallel scheduler attached to super parallel hardware like GPUs, this is sort of a perfect match for building things like complex ML pipelines. Right? And so this is something we're super excited about that's landing with the next version of Nomad. So as we talk about 0.9, it's really kind of this focus on how do we make the system smarter and richer as we see these different use cases emerging. And so there's a whole host of new features. The 0.9 preview will be available shortly, maybe as early as next week. And the generally available release should be as early as early November. So keep eyes peeled. And now I'd like to introduce Mitchell Hashimoto, founder and CTO of HashiCorp, to the stage to tell us a little bit more. Thank you so much.
Hello. Hello, everyone. So I want to start by talking about Consul. The room is pink for Consul. So it's been a really big year for Consul. Last year at HashiConf, we announced Consul 1.0. Consul has been in use by thousands of companies at very high scale for many years. And so last year, we were super excited to announce 1.0. And this year, we've been really focused on improving those existing features of Consul, but we also, earlier this year, introduced a brand new feature into Consul for secure service connectivity called Connect. And I want to start by taking a step back to talk about the original problem that we built Consul to solve, and by doing this, help sort of explain and paint the picture for why we're building these new functionalities directly into Consul, and what the future also holds for Consul. And so the original problem that we really built Consul to solve was the new challenges introduced by breaking down monoliths into discrete services. And so historically, we started with a monolith. And with monoliths, when one subsystem wants to talk to another subsystem, such as A to B here, it was pretty easy. It was an in-memory function call. One class calls an exported function of another class. All the data is in process. The network's not involved at all. It's fairly straightforward. And when that monolith needs to talk to one of its upstream dependencies, like a database, then that's usually configured with a static IP. In the monolith sort of view of the world, there's not many upstream dependencies. Maybe there's a database, maybe there's a cache, but there's not many things. And so we could just assign static IPs, hard code them into the configuration files, and just connect directly. And then when we want to control who has access to this thing, we put a load balancer in front of it, and we scale horizontally by adding more monoliths, or we scale the backend tier similarly. And then to protect all this from a security perspective, generally you would break this into a few discrete zones. You would have the demilitarized zone in the front, the Wild West, where everyone's trying to hurt you. You would protect that with a firewall, allow application users into your application, and then you would protect very sensitive data, the actual data lake, with another firewall into the back, so that only applications access data, and they're not behind the load balancer allowing user access. A pretty straightforward and common approach. So that's all well and good. What changed when we started splitting monoliths into microservices? So we started by taking this and realizing we could break this up into discrete network-connected services. The first question is, why would we even want to do this? Well, breaking it up has a number of benefits. It lowers the surface area of each individual sort of application that we're deploying, so it's easier to reason about what features we should add, how do we test it, how do we test it across the board from unit testing to integration testing. We could deploy separately from the other subsystems, and also more downstream services can consume the same shared upstream service. So if you had 5 applications before that all needed subsystem B, they don't need to compile in a copy of subsystem B into each one. They could all network connect back to one. So there's a lot of benefits here. There's more. But there's no real free lunch here. By breaking down these services and getting more agility in what we do, we've also made a trade-off for new operational challenges. And the first challenge we really run into is that of discoverability. Before, when subsystem A needed to talk to subsystem B, the service discovery tool that handled this for us was our compiler and our linker. They would discover the right memory address to jump to, and you would just jump there and execute code. Now, these are network-connected services. The compiler and linker cannot be used for service discovery, and we have a challenge of how do we find how to talk from A to B. That's problem number 1. Problem number 2 is configuration. When you have one monolith, usually it's fairly easy to configure this thing. That sort of era of application is also heavily correlated with not very many replicas, large servers and not very many replicas. And so you would just put a giant configuration file that configured all the various subsystems of your application right next to it. Maybe this is a giant XML properties file or whatever it is. It's not hard to orchestrate. There's not very many servers, and you just put it there. Now you have many more services. And in this basic example of 4, it's not hard to really comprehend, but realistically you're aiming for hundreds or thousands of services. And now there's a real challenge that's non-trivial for how do we distribute configuration, how do we try to make that configuration almost atomic in its shift, so we're not waiting an hour where one service is configured with version 1 and one is configured with version 2, and how do we actually get visibility in what that consistent configuration should be. There's more questions that arise here, but the general category and problem is that of configuration. And the last challenge is this security challenge, and the one that I'll dive into a little bit more. So in the monolith world, we solve sort of security by breaking up our zones into 3 separate zones separated by firewalls. And the way we do this, the sort of category of solution that we use here is segmentation. And so when we talk about network segmentation, it's really the concept of breaking down a network into a number of subnetworks and controlling the access between them. And the issue with this is it's a fairly coarse-grained approach that has absolutely no idea of the applications running on top of it. So you're saying segment A could talk to segment B or vice versa, and if you deploy the application into the wrong segment, then you've inherently sort of broken the functionality of that application because the security is defined at a different layer. But when you don't have that many applications and you have a fairly flat network, this is an easy approach to do, and it solves the problem by separating the security problem from the deployment problem from the developer problem. It's sort of a traditional, historic, sort of siloed approach to breaking down problems. And it works when it's small. The challenge with microservices and when you start breaking things down is the access patterns aren't as clear. You don't have a clear external to internal, internal to database sort of data pipeline happening in your infrastructure anymore. Now the arrows are going a little bit everywhere. So in this example, we have A talking to B and C. We have C and D talking bidirectionally. We have B talking to D, and nothing else should be able to talk to each other. And if you try to imagine, how do I solve this with firewalls, you might be able to see a solution, but you're already sort of requiring here at a minimum of sort of 4, 5, 6 firewalls between these various services and the complexity of configuring these. And people try to do this. Very commonly, they try to do this. And the real challenge is as you scale this up. Because the reality of adopting microservices is not that you're breaking down a monolith into 4 services. Maybe that's the initial step. The reason people adopt microservices is the expectation that one day you're going to have dozens or hundreds or thousands of services. And it's really going to look like this. And so now, when you look at these connections going around, try to imagine, how do you configure firewalls? Whose job is that? What effect does that have on your deployment speeds? And you start to realize the challenge. The other thing we've realized is that these companies breaking down into microservices very often aren't single cloud. They're on multiple clouds and multiple platforms. So you'll have some things on cloud, you'll have some things in a platform like Kubernetes, and you'll have some things on-prem, and they're not silos. They want to talk to each other. The database might be on-prem that a service in cloud needs to talk to, and how does it get there? And how do you actually do security between these two totally separated networks? And so ideally what we'd like to do is create these pairwise sort of rules that service A could talk to B, service C and D could talk bidirectionally, and then create the other set of pairwise rules around A could talk to C and B could talk to D. We want to be able to make these as our segmentation rules for security. And so these are the 3 problems that we see when you're breaking down a monolith into microservices. And we consider them the fundamental problems of really adopting microservices. There's more sort of challenges ahead, but unless you have answers to these, it's hard to really get there. And we combine these categories into what we believe a service mesh must solve in order to provide this base functionality. And for many years, Consul has solved the discovery and configuration problem. Since Consul 0.1, we've supported DNS for service discovery, a nice lowest common denominator approach that any application can integrate with very, very easily to find anything else. Just make the right DNS call, you get an IP address, and you connect right to it. For configuration, we've had a KV store in Consul so that there's a centralized place that supports blocking queries for immediate updates, a central UI so you can see what all the configuration is across your services, and that's in the KV and been there since 0.1. The segmentation problem is one that historically we've had our users look elsewhere. You've had to find other tooling to solve this problem. And a lot of our users were solving this by tying Consul very closely to systems like HAProxy or other sort of firewall type layers in front of their services. But we heard time and time again from our users and customers that Consul was just so close to solving this for them, and they really wanted to see the solution. So for the past couple years, we've been sort of planning how to make this a reality, and we talked to some users and customers last year as well about previewing what we were planning on doing. And then earlier this year, at Hashi Days Amsterdam, we announced Consul Connect. And this is built directly into Consul to solve this problem. And this is also why it's not a separate tool and is built directly into Consul, because we can't solve the segmentation problem without also knowing where our services are and what their configuration is. And so naturally, if we built this separately, we would have had to build a plugin interface. We would have integrated very closely with Consul anyways. And by doing it all in one, we've dramatically simplified the deployment and made Connect a much more adoptable, practical tool. And so that was Connect. It's a feature for secure service-to-service communication using automatic TLS encryption and identity-based authorization, and it works everywhere. And I'm just going to really quickly go over what Connect is in more detail rather than the problem. So Connect is comprised of 3 major features. It's a service access graph, it's a mutual TLS and CA, and it has a pluggable data plane. The service access graph is what defines who could actually communicate to each other. We use something called intentions to define what services can or cannot communicate to each other. These are defined using the service names and are completely separate from the hosts that they're on. So you could deploy these services anywhere. You don't need firewalls. You don't need to do network segmentation because the security is handled at the service name layer and not the IP layer. Another benefit of this is it's scale independent. So if you imagine you have a web server, let's say 10 copies of a web server and 3 instances of a database, and they're running on separate hosts, the firewall rules for that are either on one side coarse-grained, where you're saying this block of IP addresses that might include IPs that aren't running the application can communicate. It's sort of like what Armand said earlier. It's sort of the simple policy side. Or you have the highly complex, we're going to create a pairwise, this IP could talk to this IP for every single instance, and you end up with sort of a multiplicative explosion of firewall rules. Either way is really complicated and really expensive because there's a lot of rules to process, and it's hard for both people and technology to manage. The service access graph is a lot simpler. Since it happens at service names, it's completely scale independent. 10 web servers, 1,000 web servers, 3 databases, 300 databases. It's just one rule, right? This service can or cannot talk to this other service. And that's really important because that enables us with Consul to replicate the whole service access graph across the entire cluster really cheaply for incredibly high-scale deployments. The second thing we have to do is establish identity and security and encryption. And we do this using mutual TLS. So TLS is sort of a perfect protocol for us to use here because TLS was designed specifically for zero trust networks, the public internet, right? That's designed for a case where the client really can't trust the destination, and we need to, and it's happening over untrusted networks, and we still need to establish trust in some way. And that's exactly the mindset and philosophy we're trying to bring into private data centers as well, cloud private data centers. And we do this using TLS. TLS provides the identity and encryption. So the identity is baked directly into the certificate, and the encryption happens sort of by nature of the transport protocol of TLS. We also built APIs for getting the public certs and issuing new certs directly into Consul. So Consul does this by fronting real sort of CA providers. Consul itself has a built-in CA, so you could use Consul right away, but it's completely pluggable, so you could bring in Vault. We're working on integrations with Venafi and many more CA providers, but in front of that is a consistent API for verifying certs, signing certs, and more that every application and Consul agent can use. And the really powerful feature that we built on top of this is built-in rotation. One of the biggest challenges with TLS and mutual TLS everywhere and many certs everywhere is how do we safely rotate them? Initially getting them out is sort of a tractable problem, but then thinking about we'd like to rotate those relatively quickly becomes really challenging. And Consul handles this automatically for you. So we advertise short-lived certificates. I think the default's around 3 days. And then after 3 days, we automatically rotate, serve both, and after all the traffic sort of drains out of one, start serving exclusively the other one. And more sort of impressively, we also rotate the CAs for you. So you could rotate intermediate keys, root keys, and actually the whole CA provider. You could switch from the built-in to Vault, to Venafi, back to Vault, sort of whatever you need as your organization changes. And we handle automatically sort of cross-signing CAs, issuing those cross-signed certificates, the right routes, waiting for the traffic to drain, and flipping over, so that the whole time during the rotation process, your connectivity is preserved across the whole cluster. And we could do this across every service all the time. The last thing is the data plane. And when we talk about service mesh, it's really important to separate the concept of a control plane and the data plane. The control plane is what's defining all the rules. Who could talk to who, sort of what are the configurations of everything. And that's where Consul firmly sits. It is a control plane solution. The data plane is the thing that's actually sort of sitting in the path of data, verifying the certificates, consuming the configuration from the control plane, and reacting to that. And for Consul, it's a pluggable data plane. So we have a built-in proxy into Consul, and we just do that so deployment's easy, but it's not really meant for production, high-scale usage. For that, we bring in pluggable proxies, and you could use whichever sort of proxy you want to use. Visually, what this looks like is this. You have the Consul client, which is the control plane configuring a proxy. You have an application that's using Connect that wants to talk to another application. It goes through a local sidecar proxy, which is very performant just because it's over loopback, and most operating systems optimize this heavily. It goes over the network and then goes into the application. And these proxies are totally pluggable. So you could drop an Envoy there. And I think more importantly, you can mix and match. So one side could be the built-in proxy, the other side could be Envoy, it could be anything else. And as long as it speaks the connect protocol, which is just mutual TLS, it's not anything sort of novel or exotic, then it all works. And this is really important for deployments across heterogeneous workloads, which is sort of the bread and butter of what HashiCorp does. If you have one server that's on Linux and you have another server that's on Windows, the best of breed proxy, the best performing proxy might be totally different, and we allow for that heterogeneity. Or if you have one side that's really not performant dependent at all and just wants to use the built-in proxy, that's totally fine too. In addition to Connect, we've made huge strides on the UI. So Consul's had a UI for many years, and we haven't updated it in over 3 years. And this year, we released a brand new UI that supported every feature of the old one and has also added new features, such as sort of the Connect intention management. And thanks to our awesome UI team, we've also been shipping features right away with support in the UI. So the same day features come out, we're also supporting them directly in the UI, which historically we've never been able to do. And in addition to shipping these features, we've also been improving the core of Consul to make the stability and scalability better, just for the core features that existed for years. So back in July, we were really excited to work with a user on seeing the largest single data center deployment of Consul ever. Their single data center deployment was 36,000 nodes. And we have larger deployments by node count across multiple data centers, but this was all in one data center, all one single gossip pool, gossip network. And it was really, really amazing to see. It didn't come for free. We had to make dozens of improvements sort of in the core of Consul. But the benefit is that these improvements benefit everybody. So everybody, as they've upgraded Consul, will see sort of lower CPU usage, less network consumption, and more stable leader election under sort of pathological conditions. And it just makes everyone's deployments better thanks to these large-scale deployments. At the same time, we have a user right now that's preparing to test Connect, which I just talked about, across 20 data centers and thousands of nodes, which is really exciting because that becomes one of the largest sort of production service mesh deployments in the world. And so what I want to talk about now is Consul 1.4, which is something that is available today in a preview version and we've been working on for a while. The first thing we've done in Consul 1.4 is integrate deeply with Envoy. Envoy is a high-performance, production-hardened proxy, and now you could use that directly with Connect as an option just as easily as the built-in proxy. We automatically configure Envoy, we'll run it for you, and more. Our Kubernetes integration also uses Envoy by default, so you don't have to do anything, and we're just running their Docker images for you. And we also expose the ability for you to pass through custom Envoy configuration. So if you want to configure layer 7 routing, observability, and more, you could do that through Consul through the pass-through Envoy configuration. We'll look at adding more of those features first class in the Consul, but this is a great way to get all those benefits without having to wait on us. And just to look at how easy this is this isn't just a demo, this is sort of like a real configuration you might see in production, is when you define a service, you would define that you want a sidecar for that service, and then to run Envoy, it's one command, Consul connect Envoy, and then specifying which service you want a sidecar for. And what we do there, Envoy isn't the easiest thing to configure. We generate the Envoy configuration. We set up the right network addresses to point it back to the Consul agent. And then we fork an exec and start Envoy for you for whatever's on the path. So you could use multiple Envoy versions as well. And this just gets it running really, really easily. The other thing that we're bringing in Consul 1.4 is a revamped ACL system. So the ACL system in Consul hasn't really been touched since early versions. And since then, we've shipped 2 other ACL systems, policy systems, in Vault and Nomad. And we've worked with customers at very large scale and learned a lot about how to improve the ACL system and what works at that scale. We've now brought the same systems and same learnings that we've had there back down to Consul into a new ACL system in Consul. This has a number of important features. We've first separated the access token from the policy, so you could have multiple policies and assign tokens to those. You could also now restrict policies by data center. So certain policies are active only in certain data centers. We also support exact match policies. So before, everything was prefix match in Consul, which made it difficult in some scenarios to get exactly the right security that you wanted. And then finally, as a performance feature, we introduced DC local tokens. So data center local tokens are tokens that aren't replicated globally. And so generally, you could have thousands of these in a single data center without pushing sort of any replication burden onto your global deployment. And this is super important for performance. The ACL system is completely an open source. It's backwards compatible with the existing ACL system, and we've done some really neat things to upgrade you. A big part of that is the UI. So this is an example of one of those features where day one, right at launch, we support the new ACL system directly in the UI. And a really cool thing we could do with things like a UI is when you come in here with a previous ACL system, which, like I said, is backwards compatible, you're using the old one, we will guide you through a multi-step flow to upgrade those tokens for you. We'll guide you to take the ACL, turn them into policies, set up the replication for those policies, and associate them with multiple tokens while preserving the exact same access token ID so that none of your applications need to actually be rotated. They'll still keep using the same secret, but in the background, we'll be upgrading that to the new system. So check out the UI, check out the new ACL system. It all works really great. And the last thing that's really exciting that we've been working on is multi-data center connect. So one of the major restrictions of Connect when we launched it in June was that it only worked within a single data center, 2 services within a single data center. Now, with Consul 1.4, a service in Data Center 1 can communicate to a service in Data Center 2 with an end-to-end TLS encryption across the whole thing that is authorized using our intentions. So you could say, web can't talk to DB, and if DB is in a totally different region, we'll enforce that across, and we'll ensure that it's encrypted all the way end-to-end across. To make this possible, we replicate and manage the replication of the certificate authority across the multiple data centers. And the important thing is this works with any provider. So the provider backing Consul does not need to be multi-data center aware at all. Actually, what we've found as we've investigated new CA providers is that very, very few CA and PKI solutions work across multiple data centers. And so using Consul, we sort of replicate and manage that global distribution of certificates for you. And this is pretty much magic to see. This is a feature in Consul Enterprise and is available as part of 1.4. So Consul 1.4, as I said, is available today as a preview version. You could go download it right now and see all these features right now. And so next, I'm super excited to introduce Paul Hinsey, who's going to be talking about Terraform. He's our director of Terraform right here at HashiCorp.
Hello. Hello, HashiConf. Hello, over 1,000 people in this room. This is pretty incredible. Hello, live stream people. Hello, future video watchers. I am speaking to you from the past. My name is Paul Hinsey. I am so ridiculously honored to be here to represent to you all of the hard work that has gone into Terraform over the last year, and to talk with you a little bit about what the next year of Terraform is going to look like. So much to share with you. I want to start with a couple of just progress updates. So here are some numbers. Some of these numbers are absurd. So 1,200, more than 1,200 contributors to Terraform. That's more than fit in this room. So if we had brought all of the Terraform contributors here, they would not fit. We would be a fire code violation. I'm actually curious, are there any Terraform contributors in the room? Anybody have a PR accepted to a provider, a docs update? Awesome. Look at all them. Thank you. That's great. Yeah. The other number here that is really exciting is that providers number. So providers are the plugins to Terraform that allow it to address different APIs to manage more resources. 160 plus. That number has skyrocketed in the last year. Mitchell's actually going to talk a little bit later about how we pulled that off. But these numbers just show you the adoption of Terraform has been just incredible to continue to watch. The other 2 numbers I'd like to share with you have to do with our announcements from last year. So last year we introduced the Terraform registry to share modules, and we introduced Sentinel, our policy as code framework, which is integrated with all of our projects, but my favorite integration is the Terraform integration. And I'm really pleased to report that both of these new pieces of the Terraform story have become key pieces of the Terraform story. That 900 plus modules number is just public modules, and so that means there's a vast majority more of people using Terraform Enterprise to share modules amongst their organizations. And 35,000 policies checked with Sentinel already, and that number just keeps going up. So it's been really exciting to see the adoption of these 2 new features. Great, so let's get down to business. I have 2 conclusions for you today that drive 4 announcements. And if I do my job, I think you'll see how they all fit together into the way that we're approaching Terraform generally. So looking at generally at all of the things I have to show you, it really comes down to a theme of listening and reacting to the Terraform community. We spend all of our time talking to users, talking to customers, and I think you're going to see that the announcements that we have for you today are driven from community feedback, every single one of them. A lot of them from conversations that have happened at HashiConf's past. So I hope you feel that you're participating with us in the development of our projects and our products, because that's really how it feels to us. And so one of my favorite things about working at HashiCorp is how principles-oriented we are. And so I mapped my theme to 2 of our company principles. You can read about our principles on our website, or you can just hang out near me, and I will blab on about the Tao of HashiCorp. But yes, I think if you're interested in learning how we approach problems and solutions, that's great material for you to read. OK. Getting into it now. Conclusion number 1 is that Terraform needed deep language improvements. Now, we're proud of HCL, and we think that it has been key to Terraform's success, and we've been improving it incrementally over the years. But the user feedback about points of friction started to stack up against limitations of the language. And the list of things that we wanted to improve that were being hindered by the core engine of the language got so long that we needed to draw this deeper conclusion so that we could take bold action. And so you'll notice that this is in past tense, because this is the conclusion that has been driving our work for the better part of this year. This, of course, is Terraform 0.12. Terraform 0.12 is so huge. There are so many features. I could spend the rest of the day just talking to you about Terraform 0.12 features. If you're looking to learn about 0.12, you are in the right place. I wasn't going to put anything in, and then people are like, oh, you can put in a couple. So I'm very excited. I get to show you just a couple of the features. So the whole thing about Terraform 0.12 is a richer type system and a richer language engine underlying the whole of Terraform. So here's one of my favorite features. The new for keyword allows you to iterate over lists and generate lists and maps. So this gives you a whole bunch of new flexibility. It's a new primitive that I think is going to feel like a lot more elbow room in manipulating data as you pass it between modules. So you can see here, I'm just generating a map of instance ID to private IP, iterating over the set of AWS instances in my vicinity. This is really going to help the flexibility of the language. Speaking of flexibility, this one's great. You can actually pass a whole resource as a module input or an output. This is massive because it takes away a lot of the boilerplate of having to explicitly choose attributes that you have to pass in and out of each module. So I can pass the whole VPC in here, and the module can just use what it needs. So here's the other side of that. Now we're inside of that module. Here's a type declaration using this new rich type system. And you can see I've named an object here, and I said I just need an ID that is a string. So the VPC resource matches this type signature, but I could also have this passed in as a literal. And my favorite thing is if you mess it up. So here's an example. I went back out of the app module, and you can see I've passing in a literal here that doesn't have an ID. You get the best part, which is these rich error messages. The context that the language engine gives us, yeah. The core engineers, I was just flipping out about these error messages, and the core engineers who have been in the engine of 0.12 were like, really, it's error messages that you're most excited about? And I'm like, yes, absolutely. So yes, the language engine gives us so much more context at the site of the error that enables us to present all of this information to you. So you've got context here. You've got cross-references to other module definitions. A lot of times you'll actually get a suggestion about a misspelling of an attribute. So yeah, the error messages in 0.12, I think, are just a total game changer for day-to-day writing of Terraform configuration. And those are only just a couple of the features in Terraform 0.12. I don't have any time to continue, even though I really want to. So here's how you can learn more. 3 ways you can learn more. We've been posting a blog post series where we spend a little bit more time with 1 or 2 features in each post. That gives a really great way to sort of scroll through and read about the new features. Tomorrow on this stage, Kristen Lammert, our core engineer, is giving a live tour of 0.12. So check out that if you're interested in learning more. And I'm so ridiculously excited to announce, we have a build for you. Terraform 0.12 is here. The alpha build. The alpha build is released. It is out there. It is an alpha, so there are things we're still finishing. So you have to read the release notes before you give it a try. But the language ergonomics is there. The language engine is there. So and HashiConf's a great time to download this, try it out, let us know what you think. It's been a long road. It's been a long road for us, believe me. But it's gotten us so many improvements, and it's gotten us a foundation for the future. As we begin the march to Terraform 1.0, this is the undergirding of the overall Terraform engine that is going to get us there. So really excited about that. Now, my second conclusion. My second conclusion is a really big one, because this one drives all of our work and is for the next year. And this one is that collaboration is a universal problem. Okay, what do I mean by that? So we've always known that as organizational complexity grows, so does the need for collaboration in Terraform. This is the work and the attention that we've been paying in Terraform Enterprise. We've been building out Terraform Enterprise as this world-class collaboration platform to solve the problem of Terraform collaboration. But what we've come to understand in conversation with our community is that collaboration starts as a problem from the first time that you want to use Terraform with somebody else. Our original instinct was the idea that because we're infrastructure as code, generalized CI and VCS systems would be enough for collaboration. But what we've come to understand is that there's really a tooling gap in terms of managing some of the specifics of Terraform workflows as you try to collaborate in smaller teams. And if you're looking for evidence of this conclusion of this tooling gap, I think the community trying to solve this problem is great evidence. There are several projects out there that try to help close this gap by providing a solution for Terraform teams to collaborate. And so we looked at the field, we listened to our customers, and we realized we're sitting here on a world-class collaboration platform and watching the community having to solve this problem for itself. And so here's the active version of this conclusion, is that we want to be able to solve Terraform collaboration for everyone. So this is going to drive my next 3 announcements, and it's going to drive our focus of our attention for the next year. Here's the framework that we're going to be working in. Terraform Enterprise is going to remain the world-class collaboration platform that it is, but what you're going to see us working in this framework of introducing solutions for small teams on a free tier. We're then introducing sort of progressive, affordable tiers for businesses. The goal here being that teams needs scale, and their problems change slightly. So we're going to be basically designing solutions to fit the need of every size of team and teams using Terraform. So if that's our framework, what's our first step? What would be a good first step? What is a problem that is always there in Terraform collaboration? Everybody's laughing because they know this is the first hurdle, the Terraform state, a pesky Terraform state file. So Terraform state model, it's where it derives a lot of its power, but it is the first problem that you have to solve when you're collaborating with somebody else. I have this file. I know I need to store it somewhere central and somewhere secure, and I need to make sure that as I'm sharing access to this state file with everybody else, that we're serializing and we're not clobbering each other's changes. So we said to ourselves, OK, well, that's a problem. I think that's a problem we can solve. So that's what we're going to do. So I'm pleased to announce that we are going to offer free remote state management for all Terraform users. This is the core technology that is inside of Terraform Enterprise that we are going to make available to everybody as the first step in our free collaboration tier. This is designed for collaboration, which means we're not putting limits on users, we're not putting limits on the number of workspaces, and it's designed for security and stability, which means you get per operation locking. Obviously, it's HashiCorp Vault encrypted, and each workspace has version storage for easy rollback. Our mission here is collaboration on Terraform for everyone, and this is a strong first step, and we hope you think so too. I'd like to invite you all to join us on this journey of collaboration for everyone. app.terraform.io/signup will get you on the wait list, and the beta begins later this year. We're really, really excited about this. All right, so I said that's the first step. So what's next? So if we have this big resolution about Terraform collaboration, where are we going from here? I'd like to introduce you to Mishra and Luke. Mishra and Luke, when they worked at Hootsuite, they built and then open sourced a project called Atlantis. Now, Atlantis is one of those tools that's been trying to fill that gap in Terraform collaboration, and it's really produced a good workflow for Terraform collaboration for teams that's been serving its community really well. Now, Mishra's actually been a developer advocate here at HashiCorp for about a year, and Luke has been maintaining Atlantis solo, full-time, on his own for about 9 months. So we've been talking. We have this new mission about Terraform collaboration. Mishra and Luke and the Terraform team at HashiCorp have been talking, and what we discovered in chatting is that our vision for Terraform collaboration is very compatible. And so I'm happy to announce that the Atlantis team has joined HashiCorp, and we're going to work on Terraform collaboration together. So Luke's got a great blog post. If you're a member of the Atlantis community, Luke's got a great blog post that explains the details of what he's like of his side of this story. The short story is we're putting our heads together on this mission of Terraform collaboration. Luke is going to, in the near term, continue to maintain Atlantis just like he has been. Mishra is going to continue to be our man in the field, so he's going to continue his work as a developer advocate. But we're really excited to put our heads together and really come up with a cohesive story for Terraform collaboration from day one to all the way up to a massive organization. Okay, so speaking of massive organizations, I'm talking about this journey, right? So what's next for, we've got a great first step with remote state management for free. We've got the Atlantis folks on board to help us chart this course. What's next for us? Well, I mean, you kind of already know. For what's next for our customers is already here. We have been working on the problem of Terraform collaboration alongside of our customers since the inception of Terraform Enterprise. And this represents the cutting edge. This is where we are doing our innovation. And my final announcement shows you the leading edge of that. Now, Terraform itself has always been about one workflow across multiple providers, and Terraform Enterprise has always been about one workflow for Terraform collaboration. But what we've seen in talking with various kinds of organizations is as you have adopted Terraform CLI and workflows around it, just making the switch over to the collaboration workflow provided by Terraform Enterprise was sometimes a bit of a hop. And so we wanted to just solve that problem. We wanted to merge these two workflows into a consistent stream. And so that's what Remote Plan and Apply do. We're really excited about this feature. This is the unification of Terraform CLI and Terraform Enterprise that we've been working on for a long time. Let me show you how it works. It all starts with just a regular old Terraform plan. Everybody knows a Terraform plan. But this Terraform plan is wired up via the enhanced remote backend to Terraform Enterprise. And so instead, what I get, instead of just the plan output, what I get is a URL that allows me to share this plan output with my coworkers. I get access to all of the variables securely stored on within Terraform Enterprise. All I need is a TFE API key. And I get the streaming output from that plan right in my CLI. This is not only about adoption, this is about daily workflow for all of our Terraform Enterprise users, because this plan is a speculative plan that's using just the config that's in my local directory. So no longer do I have to make a pull request to get the feedback from the plan that's being run inside of Terraform Enterprise. I can just do this over and over again from my terminal as I'm working on Terraform config. It's really changes the day-to-day experience of writing Terraform in a large organization, and honestly, brings it back around to that day one experience where you just have one directory full of config. So we're really excited about closing this loop. Oh, and you also get the output of Sentinel policies. This is really cool because you can basically take the Sentinel policies that your organization has been writing to make sure that all of your Terraform is meeting the company's needs, and you can get the feedback on those policies right in your terminal. One guy really likes it. So Terraform Apply works the same way. So Terraform Plan works whether you're using VCS to drive the actual Terraform Apply or not. But for teams that are using Terraform Apply, maybe like running it from your laptops or often running it from a CI system, it works exactly the same way. You get the integration with Terraform Enterprise, you get the system of record of Terraform Enterprise, and you get the application of Sentinel policies. This creates a new way of introducing Terraform Enterprise without changing the existing workflow into an organization, getting the benefits of Sentinel, and getting the benefits of that module registry that's built in. So this is about Terraform Enterprise adapting to your workflow, creating a single unified workflow for Terraform across organizations, small and large. And this is available in a preview release to our enterprise customers today. But what I think is so exciting about this next year is you're going to start to see the functionality that shows up in Terraform Enterprise. We are going to be fitting that functionality downstream to all of those tiers, to all of that. So Remote Plan and Apply is a piece of functionality that you will see eventually available to the whole community. So we're just so excited about being able to have this sort of gradation of released functionality. So, to review, we've been listening. We have been listening to your feedback. We have been hard at work on the core of the Terraform language in 0.12, and we're really excited for you to play with the alpha build and let us know what you think. And we're dedicated to solving the collaboration problems in Terraform for all users with a first step of free remote state management. We've got the Atlantis team on board to help, and Remote Plan and Apply is Terraform Enterprise becoming more flexible than ever and represents the future of what we see for Terraform collaboration. Thank you so much for your time. I'm looking forward to chatting with all of you at the conference.
Awesome. Thank you, Paul. And can we just have one more round of applause for the whole Terraform team? They have been hard at work and are so excited to see this all out to preview to everybody. All right, so next I want to talk about ecosystem. So a core element of the Tao of HashiCorp is workflows, not technologies. And this mindset is actually also part of our name. The Hashi in HashiCorp, which also happens to be in my last name, means bridge. And we did do that purposefully because we want to build software that supports organizations wherever they are, whether that's VMs versus bare metal, whether that's cloud, whether that's containers, schedulers, and so on. We want to meet you where you are, and we want to build a workflow that works across these technologies. So Terraform Apply could create resources in cloud, could create vSphere things, SaaS things, much more. Nomad Run could run things in Docker, could run things in QEMU, could mix and match those things together. Vagrant Up can spin up development environments in VirtualBox, VMware, Docker, and the cloud. And all of these same workflows enable technology flexibility. This has immense value to organizations because you only need to educate the workflow once, and as sort of new paradigms come up, the workflow should still work while you learn about that technology. And this year, we've made a few major investments into certain parts of the ecosystem. The first of that is Kubernetes. So as we've looked at Kubernetes, we've focused on two major sort of different deployment models that we've seen with our customers in Kubernetes. The first deployment model is the one on the left. This is sort of the Kubernetes native or Kubernetes first environment. This is where all your workloads are running on Kubernetes. You're aiming for 100%. And this is really common in startups, small companies, or in greenfield arms of large companies. Then on the right, we have what we like to just sort of call mixed mode Kubernetes. This is a much more realistic deployment model for an existing company. And in this model, whether you plan on being 100% Kubernetes or not, there is a long multi-year period where you have workloads that need to interact between multiple environments, usually Kube, the cloud, and often also your private data centers. And these two environments have two very sort of unique, different challenges that we've been looking at. So the Kubernetes native side of things, what we've been trying to do there is create an experience for our products where you don't need to leave Kubernetes. Because we've found that if you need to leave Kubernetes in this sort of environment, immediately that solution is a second-class option. And so what we've been doing to enable these environments is creating official Helm installers, so you can install our software directly within your Kubernetes cluster. And we've also been looking to enhance existing Kubernetes features rather than trying to replace them. So when you look at something like Consul, we don't try to say you should use Consul DNS for service discovery, because Kubernetes already builds in first-class, very feature-rich service discovery. And so instead, what we do is say we'll sync our service catalog into Kubernetes so you could continue as a developer to use those first-class features that the platform gives you and experience Kubernetes in a native way. Then there's mixed mode Kubernetes. And the most important thing for mixed mode Kubernetes is solving this workflow problem. How do we get a consistent workflow to solve multiple challenges, with these challenges being serving and consuming applications across platforms? How does a service in Kubernetes talk to a service outside of Kubernetes, and how do they sort of do that securely? How do you manage resources required to both run and run in Kubernetes, and also run outside of Kubernetes? So I'm spinning up VMs, I'm spinning up pods, I'm spinning up deployments, and I'm at on-premise infrastructure. Are those two completely different tool sets, or can those be one? There's security challenges, and also even with sort of just Kubernetes, there's challenges around multi-data center Kubernetes, and how do you bridge those gaps? And so we've been looking at this as well. And to go through each product and how we've done this, let's start with Consul. So earlier this summer, we published a blog post where we outlined our big plan for integrating Consul with Kubernetes sort of initially. And we've delivered on every aspect of this plan today. It's all available now. And what we've done is we've published and support an official Helm chart for Consul, running everything needed for Consul directly within Kubernetes. We've extended our cloud auto-join functionality to support discovering other clients that are running within Kubernetes, which is extremely important for sort of nodes running outside of the Kube cluster to join servers running inside the Kube cluster, which is a common deployment pattern we see. We've shipped service catalog sync so that services outside of Kubernetes could just use basic Consul DNS that they're used to discover and connect to services inside Kubernetes without realizing, where they are or caring where they are. And then, vice versa, services inside Kube could find and discover using first-class service discovery that they provide, the platform provides, to connect to services living on your VMs or on-prem. And then finally, we've introduced an automatic sidecar injector for your pods for secure pod-to-pod communication, so that as you deploy things, they're automatically using Connect for mutual TLS connections, both within and across sort of Kubernetes clusters. And all of this is available today. With Terraform, we have two providers directly focused on the Kubernetes community, the Kubernetes provider and the Helm provider. The Helm provider is very recently made official from our community, thanks to our community. And we also have hired full-time engineering staff to focus on these providers within the past couple months. So both of these providers are a major focus for us. They have full-time engineering dedicated to them, and they'll see rapid improvements sort of as we go on here. And then with Vault. Actually, last year at HashiConf, we announced the ability for Kubernetes service accounts to authenticate with Vault. That still exists. We've improved it, and it's available today. In the future, we're working on a number of ways that Vault can interact more with Kubernetes. We will be supporting an official Helm chart to install Vault directly on Kube. Bringing AutoSeal to open source helps immensely and is a big part of the Kubernetes strategy, where you'll be able to automatically unseal that within the Kube cluster. And then finally, we're looking at ways to expose secrets in a way that's more easily consumable for these Kubernetes native environments, from kube secrets to flex volumes and more. Those will all be available soon, and expect us to talk about those a lot more publicly before the year ends out. And so Kubernetes is one major place that we're investing. We're also investing in sort of the opposite side very heavily in the private data center. And this might sound funny because we are sort of a cloud-first, cloud-native company. And cloud adoption is, of course, happening undeniably everywhere. But what's fun is we're also seeing growing private data center investments. They're growing. They're getting bigger. And people want to move workloads into the private data center. The tools we've built enable what we call the cloud operating model, a mindset of both tooling and philosophies that enable you to be more self-service, sort of more as-code oriented, more agile in your deployment and operations methodologies. And now, a lot of companies are interested in asking the question, can we take those learnings that we're applying to our cloud and sort of future-facing environments and bring those back down to the private data center and get those benefits right there? And the answer is yes. So here's a list of software that's very common in the private data center and plays a major component in the private data center. And so I split it across 3 categories. There's compute with things like vSphere and Nutanix and OpenStack. There's networking with things like F5 and Cisco. And then there's application level concerns, which are things sort of like Active Directory, HSMs, and more. And the really fun part about this slide is our software actually integrates with every single one of these on this slide. And how we integrate is across multiple pieces of software. So with Terraform, we support providers. We have a vSphere provider. There's an F5 provider, Nutanix, much more. For Consul, we're integrating directly with that software for things like Connect. So we're integrating with Venafi to be a Connect CA. And with Vault, for multiple years, we've integrated directly with HSMs. And we're also looking at other integrations now. And so the roadmap for private data center investment is to expand the partners that we have there and work with them to expand support in our software for private data center focused tooling. We're growing the ecosystem engineering team. Ecosystem engineering is a role at HashiCorp that's embedded directly on each team, and they work directly on these sorts of integrations. So if that sounds interesting, we're also hiring ecosystem engineers. And then we're also working on the education team and what Armand talked about with things like the Learn platform to clearly document case studies, architecture diagrams, and use cases directly targeted at private data center because we know we've heard from our customers that this is what they want to do, and they've seen immense value of using tools like Terraform to manage purely private data center deployments. And so we're going to keep doing this, and we're excited about what this holds for our customers. And then there's still cloud. We've always invested in cloud, and while Kubernetes and private data center are relatively new, we're just doubling down on cloud and remain committed. We've now partnered with all the major cloud providers all around the world, so we're not just focused on one specific region. This is from Ali Cloud to VMware, Oracle, Google, Google Azure, and AWS. And we have some great partnerships with all of these organizations. To highlight a few and show how these partnerships have worked. With AWS this year, we've had multiple launch day Terraform support items. So both EKS and ElasticMQ, the day that AWS announced the availability, we've also had Terraform support right alongside of that. We've also worked with Amazon to develop and support quick start guides for Consul, Nomad, and Vault. And these quick start guides, every single one is in the top 10% of most viewed quick start guides for Amazon. We also have a great partnership with Google. We've worked with Google for multiple launch day items as well. This year, they announced Cloud HSM, which had launch day support for Vault right away. They've helped develop the GCP secrets engine in Vault. And their interaction with us on the Terraform provider is very close, and they're very good in focusing on 100% coverage of Google Cloud resources. And then with Azure, very similarly, we had a couple launch day items, including AKS. Also, Microsoft this year announced an image building service for Azure, and that's based completely on Packer under the covers, and they're public about that. And they also announced an ARM and Terraform integration so that if you are an ARM user, you could actually use Terraform providers directly from ARM. These are all really major things that have happened just in the past since the last HashiConf. These are all brand new. In addition to our partnerships, we've launched what we call integration programs. A little over a year ago, our first integration program was the Terraform Provider Development Program. This is what Paul was alluding to earlier of how we've been able to grow providers so quickly. So as a bit of a history, a little over a year ago, HashiCorp ourselves were responsible for maintaining about 90 Terraform providers. So if you reported an issue, made a pull request, there was a team of about 5 in our company that across 90 providers had to respond to that. And we found that we were being very reactive. It was, oh, there's a new issue here, so let's go react over here. And there was less, so we couldn't plan very well because we didn't know when these things would come up. So we developed the Terraform Provider Development Program to work directly with vendors and the community to establish a relationship where we could help test, provide sort of test environments for nightlies, release infrastructure, those sorts of things, while the community and the vendors help maintain the providers themselves. And so we went from maintaining 90 providers ourselves to just 12 months later, there's 89 official providers. And 89 official providers means that they are maintained by the vendor or the community, with HashiCorp providing some support. There are 74 community providers, and these providers are explicitly unsupported by HashiCorp, but usually have a vibrant community and are documented still on the Terraform website, and are still generally good providers. They just sets the expectation there of our relationship. And there's still around 10 or fewer HashiCorp maintained providers, but these are generally quite small, the random provider, the TLS provider, things like that. All the major cloud providers are part of our partnerships now, and they're providing help there. And I think this is a major success story for Terraform because it enabled us to grow the number of providers dramatically, but also for those in the community, you've probably seen that the number of releases across things like the Azure provider, AWS provider, Google provider are much more frequent and much more feature-rich. There's a lot of stuff coming out of the Terraform community. And then there's Vault. And this is really new for us. We only launched the Vault integration program a month ago. And the Vault integration program helps vendors sort of navigate how to integrate HSMs, auth backends, secret engines, and more. And it's very similar to the Terraform Provider Development Program. So we don't have anybody has come out of this program yet, but we have 3 that are very close. We're working directly with 3 vendors that are pushing through this program, and they'll be sort of graduated soon. And we're excited to see where this goes. In addition to the integration programs, we've also doubled the number of technology partners that we work with. Technology partners are people that have a direct line of access to HashiCorp and vice versa. We share sort of elements of our roadmap, documents, training. We work with them on blog posts, marketing. We work in the field with customers to provide great support and integration help for them. And we've doubled this number, which is really great and a huge testament to our ecosystem partnering team. So ecosystem's super important to us. We're making some major technical investments, people investments, and I'm really excited about it. And now, sort of to round out the keynote, I'd like to invite David McJanet, the CEO of HashiCorp, onto the stage.
Thank you, Mitchell. As you can see, there's a tremendous amount happening here at HashiCorp. But there's a common theme to all of it that really underpins everything we do, and that is this commitment to enabling this common operating model for infrastructure. I think what's clear to us as a vendor, really, that works with many in the Global 2000 is that heterogeneity is your reality. We think you're going to have multiple cloud partners. You're going to want to leverage the investments that they're making over the next generation as they continue to build out the rich suite of services. We also think you're going to run a lot of infrastructure of your own. We think that's not going away anywhere. We also recognize that there's heterogeneity of application infrastructure. So whether it's Cloud Foundry or Kubernetes or Java apps or .NET apps or everything in between, this is going to be the collective world for all of us. To borrow a Jeffrey Moore analogy, we actually think about it, and what we see most commonly is this idea of systems of record being largely on premises and systems of engagement being built on premises, being built on cloud. And it is the bridging of those 2 worlds that is the challenge for all of us, is how do I build a net new customer engagement application on cloud that perhaps has to connect to a mainframe on premises? That is a scenario we actually see relatively frequently. So we view our role as an enabler of that. And one of the coolest things for us over the last 12 months has been to see how these cloud-native products have worked their way inside the enterprise. So it's super common today for us to see people using Terraform to provision their vSphere. We see people using Vault to basically safeguard access to systems and applications on premises. And the one we're most excited about is around the connectivity of Consul and what that enables for you across these hybrid environments, as Mitchell described. Really quick recap of what was announced we are, in a sense, 4 companies in one, which makes it a little bit difficult to communicate what's happening. But suffice it to say, we've had announcements across all 4 aspects of our portfolio, from Vault with Vault Advisor to Consul to Terraform and to Nomad. And I think this sort of sustained culture of innovation is one you've come to expect from us. I wanted to speak for just a second about the investments we're making as a company because, not surprisingly, we've seen tremendous growth over the last 12 months. And that is only because of the investments that many of you have made in partnering with us. We've had the fortune, I think, last quarter we crossed over literally 100 of the Fortune 500 are commercial customers of ours. It is that investment that has allowed us to invest in our company at the pace that we have. It is that investment that allows us to make the model work for all of us. We now have, as Armand pointed out, well over 300 employees in the company. The biggest team they're in is actually our product and engineering organization, and it always will be. That is by design. That is how our model works. We invest in product first so we can continually sustain the innovation that you see. That explains the product announcements you've made today. But I also want to touch on the support and success investments that we've made. We now have a support organization that covers literally thousands of tickets a year, many, many thousands of tickets a year, spanning all 3 time zones in the US. We now have 3 different support offices or support clusters in Europe, and we're building out our first one in Asia this year as well. We understand the role that we play for many of you in the infrastructure that you run. We understand the seriousness of that. We thank you for the partnership. Our goal is to be your partner as you navigate this transition for the next generation and beyond. And I hope you have a great time at this conference today. I know we're running along, so I'll keep it short. Thank you. Really appreciate the support. We look forward to spending some more time with you. And hopefully you can stick around for Paul's session, which is coming up next. Thank you.